Welcome to episode 23 of the Pulse of Physiology. I'm your host, Dr. Jim Davis, and today we're diving into the dynamic relationship between the hypothalamus and the pituitary gland. Today, these structures form the command center of the endocrine system, orchestrating the release of hormones that regulate vital body functions. In our next episode, we'll expand on this foundation by exploring specific hormones. But for now, let's uncover the intricacies of this critical partnership. Now, the hypothalamus is located in the brain just below the thalamus. The hypothalamus serves as the homeostatic control center by regulating blood pressure, temperature, water balance, and more by producing and releasing hormones. Now, the pituitary gland is situated at the base of the brain in the sella turcica. The pituitary gland is divided into two parts. The anterior pituitary, which is a true endocrine gland that produces and releases hormones in response to hypothalamic signals, and the posterior pituitary, which is an extension of the hypothalamus that stores and releases hormones produced by hypothalamic neurons. Now, the hypothalamus uses three types of hormones to exert control. So there are releasing hormones, which stimulate the release of hormones from the anterior pituitary, such as thyrotropin releasing hormone, or TRH. Then there are inhibiting hormones, which prevent the release of certain hormones from the anterior pituitary. For example, dopamine inhibits prolactin. And then finally, there are tropic hormones. These hormones target other endocrine glands to stimulate hormone production, such as adrenocorticotropic hormone, or ACTH. Now, hormones released by the anterior pituitary are tightly regulated by hypothalamic hormones. Prolactin is controlled by dopamine, and as we just mentioned, dopamine actually inhibits the release of prolactin. Growth hormone is regulated by growth hormone releasing hormone and growth hormone inhibiting hormone, also known as somatostatin. Thyroid stimulating hormone is stimulated by the release of thyrotropin releasing hormone from the hypothalamus. Adrenocorticotropic hormone is triggered by corticotropin releasing hormone. And finally, we have luteinizing and follicle-stimulating hormone. Both of these hormones are stimulated by gonadotropin-releasing hormone, or GnRH. Now, the posterior pituitary, on the other hand, does not produce hormones, but stores and releases two hormones made by the hypothalamus. You have vasopressin, which is also known as antidiuretic hormone, abbreviated ADH. This hormone regulates water balance by increasing water reabsorption in the kidneys, and ultimately plays a small role in vasoconstriction to maintain blood pressure. There's also oxytocin, which promotes uterine contractions during childbirth. It also stimulates milk ejection during breastfeeding, and it's involved in social bonding and trust. So this relationship between the hypothalamus and pituitary is referred to as the hypothalamic pituitary axis. And this axis integrates signals from the nervous system to regulate endocrine functions. For example, in response to stress, the hypothalamus releases corticotropin-releasing hormone, which stimulates the anterior pituitary to release ACTH, or adrenocorticotropic-releasing hormone. ACTH, in turn, triggers the adrenal glands to release cortisol, which prepares the body to handle the stress. Understanding the hypothalamic-pituitary relationship is crucial for diagnosing and treating endocrine disorders. Pituitary tumors can cause overproduction or underproduction of hormones, leading to conditions like Cushing's disease or growth hormone deficiency. Diabetes insipidus, which is different from diabetes mellitus, is caused by insufficient antidiuretic hormone, which can lead to excessive water loss. And then there is hypo and hyperthyroidism, and these are linked to dysregulation of thyroid-releasing hormone or thyroid-stimulating hormone. So let's summarize with our four key takeaways. The hypothalamus and pituitary gland form the central hub of the endocrine system. The anterior pituitary releases 6 key hormones regulated by hypothalamic releasing and inhibiting hormones. The posterior pituitary stores and releases vasopressin and oxytocin produced by the hypothalamus. The hypothalamic pituitary axis integrates neural and endocrine signals to maintain homeostasis and respond to stress. And so that's it for episode 23 of Pulse of Physiology. I hope this episode has clarified the connection between the hypothalamus and pituitary gland. Join me next time for episode 24, where I'll dive into the world of hormones and their specific roles in physiology. Until then, keep questioning, keep exploring, and stay curious.